In this video, let's check question number 3 from our model paper 1. Two particles P and Q of mass 20 grams and 40 grams are projected simultaneously with the same initial velocity and at the same angle. This is 30 and 160. If you consider the angle of projection, again it's going to be 30. So both of the angles are same and the speed are same. And we are to determine at which space and after what time of collision will particle Q reach ground. Before moving on to this question, let's discuss a important theory, the conservation of linear momentum. According to Newton's second law, we know that F is proportional to rate of change of momentum. If the unbalanced force is 0, then the rate of change of momentum also has to be 0. But delta t, the time cannot be 0, the change in time cannot be 0. The only option is delta mv being 0. If delta mv is 0, we have P final minus P initial being 0. Finally, we obtain the initial momentum and the final momentum are equal when the external force or the unbalanced force is 0. We call this the conservation of linear momentum. It is applicable when there is no unbalanced force in the system. Let's look at an example to understand better. I have a system where a 2m mass is moving right with velocity v and a mass m moving left with velocity v. If I find the total momentum, I have 2mv to the right plus mv to the left. Simplifying them, I obtain that the momentum is mv to the right. By simplifying, I obtain the total momentum as mv to the right. When these particles undergo a collision, we know each of them are going to exert a force on each other. You might have a doubt, under this situation, can we apply the conservation of linear momentum? But remember, you must consider the system. When you consider the system, these are equal and opposite forces, they cancel off each other. In case of the system, the unbalanced force is 0. Thus, the conservation of linear momentum is applicable. If the mass m moves with a velocity of v, and let's assume that the mass 2m moves with a velocity of v dash. According to our law, when there is no external force, as in this case, the momentum has to be same. So mv to the right plus 2mv dash to the right is equal to mv to the right. By simplifying, we obtain that 2mv dash is equal to 0. Since m cannot be 0, velocity is equal to 0. 2m has come to rest. That is conservation of linear momentum. Now, let's see if we could apply the conservation of linear momentum for a projectile motion. In a projectile motion, let's assume that two particles collide with each other. When they collide with each other, is linear momentum, conservation of linear momentum applicable? Let's think of this. Projectile is a combination of a horizontal and a vertical motion. If air resistance is neglected, then there is no any external force along horizontal. Along vertical, you have an external force mg. Thus, it is clear that conservation of linear momentum is not applicable along vertical direction. Still, it is applicable along horizontal direction. In a projectile, you can apply the conservation of linear momentum only for the horizontal direction. According to our question, it says that particle P traces its own path after the collision. Let's think of this. After the collision, if they don't collide at the maximum point, they will have an upward force, upward velocity too, and some velocity along this direction and maybe along this direction. There is no any opportunity for this particle to trace its own path if it has a velocity in the upward direction. Therefore, for the particle P to trace its own path, it has no choice other than colliding at the maximum. At the maximum, you won't have a velocity along upward direction. So, if it collides with velocity v and returns with velocity v, then it's going to trace the path it went upward. So, it will trace its own path. With these ideas in mind, let's apply the conservation of linear momentum. Since they are being projected with the same velocity and at the same angle, when reaching the maximum, both of the particle should have the same velocity. Let's take this as v dash. So same velocity. This particle is given as 40 grams. I'll consider it as 2m and this as m. If P should trace the same path, after the collision it should have the same velocity v. Let's find out the initial linear momentum along horizontal. That's going to be mv to the left. And as our discussion, after the collision, this should move with velocity v to trace its own path. This particle P will have a momentum of mv to the left after the collision. Initial momentum is also mv, the final momentum of P is also mv, then this particle should have a momentum of 0 along horizontal. Therefore, it will fall under gravity. It is falling under gravity because the initial at the maximum also, since it is already at the maximum, there is no vertical velocity. The vertical velocity is 0 and it is going to drop from there. It is given that the distance between A and B as r. Therefore, since they were projected with the same velocity and the same angle, they will collide at the right center. That's going to be at r by 2. The particle Q will reach ground at r by 2. And as it is being dropped from the maximum height, we can find out the time in this manner. The time taken to reach maximum will be equal to the time taken to drop down from maximum. Since the air resistance is neglected, we know that V is equal to U plus AT. Applying for horizontal vertical motion, at the maximum it is 0 and U is 50 sine 30. So half minus 10 into t. By simplifying, we have time as 2.5 seconds. So the answers are r by 2 from A and 2.5 seconds from 2.5 seconds after collision. Thank you.